Hi, everyone. Just before coming to Sweden, I was reading the paper of your famous economist, Nordstrom, and he's making prediction for the next 50 years for human being. And one of the key predictions is that Harvard diploma will not matter anymore at all. What will matter is the ability to adapt, adjust, be flexible to the new industry, task, idea, and self-educate yourself to bring the value. And that very moment, I was thinking, wow, it's about us. Data scientists, engineers, developers, we are born to adapt, right? So we can go to any industry and bring the value. We can come to the banker, for example, and tell, hi, we can protect your data from leakage. We can come to the doctor and say, we can do prediction of disease better than you can do. Another question, if they would believe us. 1 second, because I think that my adapter is not connected. Perfect. Also, we can help fashion designer to create piece of art for him, even without having any knowledge in this. After some tries and failures, I even managed to impress my grandma that AI can help her with the recipe of jam prediction. I even did this exercise, but to generate some fancy cocktails for my friends. So, adapt to industry is our magical power. It comes with the ability to get into use case and bring AI solution, which can reduce time and cost, increase accuracy, and so on and so forth. So now I want to ask you, who is the same excited about AI as I am? Okay, great. So a few years ago, I was talking to my friend, she is George, and I was telling her how powerful AI can be for sentence prediction. She was impressed, of course, but after that, I started to talk about limitations, and all the magic disappeared. Because what I mentioned is you need to have a lot of annotated data to train good machine learning or deep learning model. Second, if the law is different in different countries or even states, you need to have annotated data per each country, and you need to adapt or customize your model per each country. After that, I said that you need like 1 or more years to develop the solution. And at the end, she was killed by the fact that as soon as new law appears, you need to retrain your model again. So now I promise that we can adapt, right? So in my talk, I will focus on how we can do this. And for this, I will bring you the use case, which we do in our company. It's documents classification. So we have different unstructured documents, doc, PDF, Excel, including chatbot logs, emails, and scanned images. And we classify them in different dimensions. For example, first is business category. It's kind of topic which describes what this document is about. And it comes in 3 hierarchical levels. So the most generic one is like client data, employee data, accounting tax. After that, we go deeper. And the second level could be, for example, budgeting. And after that, we go even deeper and could be like corporate planning, etc. The second dimensionality is very easy. It's confidentiality level. The data could be confidential, secret, public, internal. And the third one is, for example, sensitivity or toxicity of the document. For example, how much personal information it contains and how sensitive it is. For example, if the document contains credit card or person name, so it will be classified as very toxic. So when I started this project 3 years ago, I was thinking that it's like work for a few months. How naive I was. It's already 3 years. We still have a lot of room for optimization. And I will tell you when the problems came. So the problems came when we moved from one industry to many industries. So we started with finance. It looked very good. After that, we moved to healthcare, luxury, insurance, airplanes. And we found that the distribution of data and documents is completely different. Right? And we need to adapt our model somehow. And the next example shows you this very well. For example, we have payslip the same document for different countries, right? So you have, for example, 4 industries: finance, insurance, healthcare. It's completely the same. My question is, will business category be the same for all these industries? Actually, no, right? So for finance, it will be, I need to check, accounting opening, right? So for insurance, it will be another type of business category. For example, when it is healthcare, you will use your per slip, for example, as you are employer in the hospital. And if it is luxury, you will bring your per slip if you want to take credit for your new watch, right? And another example is the same medical record. So when you have medical record in finance, in bank, is most likely employee data, right? But could you guess for healthcare what type of business category it will be? It's client data, right? Or patient data. Completely the same document. And I guess at this point, you might have the question, why do we need this documents classification? What is the value for these companies, right? So here is the answer. Every month, or even often, we have data breaches in the world. And it affects not 10 or 100 or 1,000 people, it affects the millions. For example, last month, in September, almost entire population of Ecuador suffered from personal data leakage. And it affects companies as well, because they get the huge fine for poor data protection. And the recordsman this year was British Airlines. And it's not necessary that a lot of data will be leaked. It's enough to have one document. For example, if Rolex lost the new watch design document, it might be the problem. It still will be released even faster, but by Chinese company somewhere in Harash, right? So these regulations, you might know, GDPR, CCPA, PDPA, HIPAA, they're giving a hard time to the business to protect their data. But you cannot protect Ferrari if you don't know what is Ferrari and how to find it in your car park. You cannot protect everything only because of this. It's because data classification or documents classification is helpful here. As soon as document has the label by business category or confidentiality, the clients can put some actions on top of it. For example, restrict user access rights for particular type of employee, or prevent this document to be sent by email to particular location, or, for example, mask the personal information inside, or encrypt the document. All these actions will help to comply with any regulations. Now we will talk about solutions. So, of course, supervised machine learning is the best. We can train the model, but we need to have a lot of domain-specific annotated data, which is costly. So here I put the example how much it will cost for organization to label data. Assuming that we have more than 1,000 business categories, we need around 500 documents per category, and we will pay this money. So we need to come with some alternatives. And actually, 3 years ago, the Andrew Ng, you might know, who is data scientist, that he predicted the growth of such techniques as transfer learning, reinforcement learning, unsupervised machine learning. And now, at 2019, I would say that it grows even faster because it comes from industry needs. So now I will start from transfer learning, as I believe it can bring the highest value for our use case. So you might know that the idea is to transfer some knowledge that model gain by solving one problem to different but relevant problem. For example, if you know how to ride bicycle, you will learn how to ride car. Or if your model is trained on Wikipedia text, you will use this knowledge to build the model for classification medical records. So here and again, I will use this terminology, source data and target data. Source data is the documents on our site, annotated documents, which we can use for model training. And target data is client-specific, domain-specific, industry-specific documents, which we will use to retrain our model on. So it is kind of dark side because we don't have any visibility on client data, especially when we come to the new industry. Okay? So depending on availability of some annotated data on this dark side, we can have different types of transfer learning. Fine-tuning, one of the type, means that we take the features that model learned on our side and we use them to create new model on the client side. For example, you have neural network, right? It is trained on Wikipedia text. What you do, you freeze first few layers, assuming that they learn the most generic features about language, like word representation, connections between words, etc. And after that, you unfreeze the last, let's say, 2 layers, and you retrain or fine-tune them on the client side with domain-specific data. By putting as an classifier, you will be able to get your labels, or in our case, business categories. The advantage of this approach is that set of labels or classes could be different in different industries. For example, if you train the model on finance data, you will have transaction, invoice, etc. After that, you fine-tune it for healthcare, you will classify into medical records, patient data. But knowledge will be brought from one industry to another. But disadvantage is that you still need to have some label data on client side, but less than for supervised machine learning. From the other hand, domain adaptation doesn't require any label data, but it assumes that list of classes is the same. So for example, in our case, it works very nice with confidentiality prediction because it's still 5 main confidentiality types, but distribution of data in different industry will be different. For example, for bank, you will have a lot of secret confidential data, but let's say for design studio, you will have public and internal data. And the model will just adapt to the new one. But we live in an era of creativity, and data scientists, of course, found the way to still have with no label data on client side, but be flexible in terms of number of classes. So it is called zero-shot learning. I think that you heard about this. The idea is very easy. I will give you a very easy example. So let's assume we have father going with his child to the zoo. And the child has never seen a panda, but saw a bear. So the father gives the explanation to the child, kind of attributes, that panda is like a bear, but smaller and black and white. Okay? Will the child be able to recognize panda? Most likely, yes. The same is the model. You take your model, you go to the client, and you tell, okay, so you saw some text, some documents, Wikipedia, like flight tickets, for example, and you know some attributes that it should contain flight number, time, and you will see more attributes, and in semantic space, it should be close to this one. And most likely, if you have attribute about reporting, you will call it traveling report. And here we assume that the model which we bring should have a lot of knowledge. And here I want to introduce you BERT. It's language model trained by Google. It's super nice, and it outperforms all the other word embeddings models. And actually, it can give us a lot of understanding between languages. We just fine-tune the last few layers, and we train it for classification of the documents. Another model which is great, it's universal sentence encoder, which allows us to do translation between languages. It means, for example, when the model was trained your classifier on English language, you can come to the client with Thai language, and you can just use the same model for classification Thai documents. And here is the example when you have few documents which for the new category on client side, which already labeled. As soon as you can add at least one document, it will be called one-shot learning. If you can add few documents, it will be called few-shot learning. You can see that transfer learning outperforms supervised machine learning in terms of training speed, but also if you have enough documents even for training good deep learning model, transfer learning will be better because you bring some knowledge from outside. Now we move further, and we will go to unsupervised methodology, which is really great. And assuming we don't have at all labeled data, neither on source domain nor in target domain. So how can we deal with this, right? We just started our company, started our startup, and we want to discover somehow what types of categories we have on client side. So here we will come with unsupervised, and I want to show you the example of our pipeline we started with. So we do text preprocessing, after that feature engineering, and after that we go with clustering. Yes, everybody of you is familiar with this, right? As soon as we have the group of documents, we do text summarization to extract some logical key phrases or keywords which will explain us the sense of these groups of documents. Okay? And the last step, it will be called auto-labeling, which means we aggregating these key phrases into topic, or in our case, the 3 levels of business category. I will not tell you about clustering, but I will tell you about summarization methods, which is really great. So it is called EmbedDOCRank. And the idea is that on the first step, we just select the candidates for key phrases. We summarize all the text in the group, and we have the list of key phrases which should be reweighted and selected as the most representative one. We project them into n-dimensional space by using word embedding model send2vec, and the same we do with document text. We also project it into the same n-dimensional space. After that, the same we do with cluster text. We project it into the same dimensional space. Our next task will be just to find the distances between all these vectors. And the phrases which are the closest to document vector will be selected as key phrases for documents. Okay? And after that, among these phrases, we will select the closest to cluster, and they will be called key phrases for our cluster. Still here? Okay. And on the next step, we will just aggregate them by using semantic relationships between words into the topic, which we call business category. But the method before is a bit not finished, because we cannot give you accuracy or F1 score how good our model is in prediction these categories, because it's unsupervised, right? So we need to come with method which will help us to validate the result and create, again, some annotated data for further step, which will be classification, supervised classification. So this method is called active learning. It's a very old method. If my grandfather were a data scientist, so he would be used this method. And the idea of this method is the next. Independent if you have supervised or unsupervised model, you always measure the confidence level of the prediction, how confident your model is in the prediction. And after that, the least certain samples of the documents will be sent to Oracle, who is like expert in domain, and will be able to annotate these documents. So here we assume that we don't want to send randomly these documents, but we want to do kind of smart selection. Here you can see also how we will deal with this problem if we have neural network, right? Because it's not easy to understand this confidence level when you have neural network. So what we do, we take the learned embeddings from the layer before the last, we cluster them, we calculate silhouette score, which was mentioned by Ravi, and after that, the clusters with the lowest silhouette score will be considered as the least certain and will be sent to the annotator. So active learning, it outperforms the random selection, as we can increase our annotated data set very fast and get higher accuracy in this case. And the last method which I want to introduce is data augmentation. So when you don't have enough annotated data and you want to be faster in increasing, you can just generate synthetic data, right? So it will reduce the cost and time. And we use this approach for scanned images. So for example, we have the documents which are scanned copies of IDs, passports, etc. And we want to use them for first text extraction and after that documents classification. But in order to annotate these documents, for OCR model, you need to do it character by character, which is very, very costly. So how to fine-tune our OCR model in easier way? So what we do, we generate the pure images from the text, just synthetic images. After that, our next task is to make these pure images the same as our original images, which means with a lot of noise, like scanned image, right? So in order to add this noise, we take the cycle-GAN generative model, which will learn the distribution of the noise of original images. And after that, we just apply this generative model on the pure synthetic image, and we get the similar to original image, but we now already have it is labeled in terms of text extraction. And we fine-tune our OCR model to get the result. Okay, so now I need to do very fast the summarization of what I said and give you some takes away, how you can deal with it, right? So first, if you want to go to the new industry, new domain, new client, how to design your pipeline. First, I will suggest you still to come with some pre-trained models. It might not help, but wonders happen. After that, if you see that you don't still have good data set to train your model on client side, you can fastly generate some synthetic data. If it doesn't help, for example, because you see that distribution of data is completely different, I would recommend you to take your time and to come with unsupervised approach. It will help you understand what is this data about, but also it will help you to explain these results and communicate these results to the client. Especially when it's text or image, you can extract the features and explain how your model came with this solution. After that, you will need some validation step, and active learning will help you here. And if you can bring some knowledge from outside, of course, transfer learning will work the best in this case. And only at the end, if you went through the steps, you enrich your training data set, you will be able to train good supervised model. But only combinations of them will give you the best results. And lastly, I want to give you my forecasting for the next 50 years. So imagine data protection is like self-driving car. You don't need winter tires if you want to drive your car even in Sweden in winter, because your car can just adapt to any weather condition. And you don't need to know where your president medical record is stored in order to protect it from leakage. Because your model can adapt, adjust, be auditable, and compliant. Is it really far future? I guess no. Because we already live in the world where, for example, Udacity used GTA 5 games in order to train models for self-driving car, and it performs very well. When Facebook uses zero-shot learning in order to understand the new languages or dialects. When IBM Watson uses the images of balloons and unicorns to predict the cancer. And even a lot of scientific conferences, they are organized just to discuss the classification of cats and dogs pictures, and after that go to industry and use them for different use cases. So I believe that it's not the future, and it's happening today. So don't miss your today. Thank you.
So if anyone has any questions. Okay, I'm going to ask you again. So does anyone has any question they want to ask, or are all of you waiting for lunch and ask her in the lunch? That can also happen.
Yeah, I think that it's time for lunch.
You started off by saying go to any industry and adapt. So do you think in the future or now the developments in different disciplines and fields will be more driven by, say, machine learning experts rather than, say, a biologist or a chemist or a doctor, or someone from that field itself?
Yeah, I think that it's a great question because it's topic of discussion nowadays in a lot of panels in a conference. So I believe that machine learning or machines still cannot be better than human and cannot take the responsibilities for the last decision, right? So only the combination of human knowledge and machine learning knowledge will help and will be the best at the end. And what machine learning or deep learning can help with, it's of course prediction and speed of training, speed of prediction as well. The next one is explainability, right? So in order to make the decision, for example, for the doctor, he needs to look at a lot of medical records, a lot of historical data. But NLP or machine learning can help to prepare these results for the doctor and speed up the process of decision making. And only at the end, when we combine the knowledge which we gain through all historical samples and the knowledge that or experience that specialists gain during his life, we will be able to find the best result.
Okay, then give it up for Tatiana again. And
thank you.